I wasn't researching water infrastructure when I first came across the photograph of those wooden pipes. I was looking through construction excavation records, the kind of dry documentation work that fills municipal archives but never makes headlines. Street repairs, building permits, utility replacements, standard urban archaeology. But then I found a 2006 excavation report from the South Street Seaport, and I stopped reading my other documents, because workers had discovered something during a Department of Environmental Protection project. 2 wooden water pipes, 12 and 14 feet long, 4 feet below ground at the intersection of Beekman Street, Water Street, and Pearl Street. The pipes were made from hollowed out pine logs, bark still attached, tapered at one end to fit together, fastened with iron bands. And according to the archaeological analysis, they'd been underground since 1799, 207 years. The report noted something remarkable. The pipes were completely intact and still connected. Wood doesn't last 2 centuries underground, not in soil with Manhattan's water table, not with seasonal freeze-thaw cycles, not with tree roots, moisture, and constant ground settling. Yet here they were, intact, connected, functioning as if they'd been laid a decade ago, not 2 centuries. When I asked the Department of Environmental Protection how that was possible, the response was brief. The pipes were heavily tarred inside and out, preservation likely due to anaerobic conditions below the water table. Likely? That word appeared 3 times in the 2-paragraph response. I started pulling records on New York's early water system. The official history is straightforward. In 1799, the Manhattan Company was chartered to bring clean water to the city. They laid approximately 25 miles of wooden pipes between 1799 and 1802. The system operated until 1842, when the Croton Aqueduct finally delivered fresh water from upstate. Standard urban development. Growing city, inadequate infrastructure, private company fills the gap. But the deeper I looked, the stranger it became. The Manhattan Company was founded by Aaron Burr, the same Aaron Burr who would later kill Alexander Hamilton in a duel. But in 1799, Burr wasn't thinking about duels. He was thinking about banking. The company's charter included a clause buried deep in the legal language. Any surplus capital could be used for business purposes, not inconsistent with state law. The company raised $2 million. They spent $100,000 on the water system. The rest? Burr used it to open the Bank of the Manhattan Company, a direct rival to Hamilton's Bank of New York. Today, it's J.P. Morgan Chase, the largest bank in the United States. So the water system, the ostensible purpose of the entire venture, received 5% of the capital, $100,000 to supply water to a city of 60,000 people, and somehow that system lasted 43 years. I found the original construction records in the New York Historical Society archives, or rather, I found what remained of them. There are building permits from 1799, financial ledgers showing costs, $45,000 spent by the close of 1802, maps showing the general pipe routes through lower Manhattan. But the technical specifications? The engineering drawings? The excavation methods? Not in the files. A librarian directed me to a catalog entry. Manhattan Company construction documents, 1799 to 1802. Collection transferred to State Archives, 1891. When I contacted the State Archives, they couldn't locate the collection. Likely lost during the 1911 State Capitol fire, the archivist explained. Likely. So the financial records survived. The general maps survived. But the documents that would explain how they actually built the underground system, how they knew where to dig, what methods they used, what they encountered, were gone. What we do know comes from secondary sources. The Manhattan Company built a small reservoir on Chambers Street. They sourced water from wells near the Collect Pond, a 48-acre freshwater pond at the current intersection of Mott and Grand Streets. They used hollowed pine logs for pipes. Workers would core out the logs with an auger, leaving bark intact. One end was tapered to fit into the next. Iron bands fastened the connections. The system was crude, low pressure. The pipes froze in winter, tree roots damaged sections, and the water itself, drawn from the increasingly polluted Collect Pond, was contaminated with industrial runoff, animal waste, and human sewage. Contemporary accounts describe it as inadequate from the start, yet it operated for 43 years, and when those pipes were excavated in 2006, they were still intact, still connected. 2 centuries underground in conditions that should have destroyed them. Think about that. On the night of December 16, 1835, the temperature in Manhattan dropped to minus 17 degrees Fahrenheit. At 9 p.m., night watchman William Hayes smelled smoke near the intersection of Exchange and Pearl Streets. He found a 5-story warehouse fully engulfed in flames. Within 20 minutes, 50 buildings were burning. The East River froze solid. The Hudson River froze. Every well cistern and hydrant in lower Manhattan froze. Firefighters drilled through ice in the rivers to access water. But when they pumped it through hoses, the water froze before reaching the flames. The wind blew the spray back into their faces. Chief Engineer James Gulick sent crews to tap the Manhattan Company's underground pipes. Nothing. The wooden system, the same system that had supposedly served the city for 36 years, was frozen solid, useless. By 3 a.m., with 17 city blocks ablaze and no water available, Lord Mayor Cornelius Lawrence made a desperate decision: destroy buildings to create fire breaks. Marines brought gunpowder from the Brooklyn Navy Yard. They blew up structures at 48 Exchange Place and along Wall Street. The explosions worked. The fire burned itself out by morning. 674 buildings destroyed. 13 acres of the city's financial district reduced to ash. $20 million in damage, equivalent to $640 million today. And 2 people dead. Only 2 deaths in a fire that leveled 17 city blocks because most people escaped. The buildings burned, but the population survived. What the fire revealed, though, was something the city had been ignoring for decades. The water system didn't work. It hadn't worked in 1799. It hadn't worked in 1820. And on the coldest night of 1835, when it mattered most, it catastrophically failed. 4 months earlier, April 1835, New York's voters had approved construction of the Croton Aqueduct. The vote was decisive: 17,330 in favor, 5,963 against. The plan was ambitious: bring water from the Croton River, 41 miles north of the city, build a masonry aqueduct that would deliver 20 million gallons per day by gravity alone, create a reservoir system that would supply a population of 1 million. The estimated cost, $4.25 million. The vote happened in April. The fire happened in December. Construction didn't begin until 1837, 2 years later. Why the delay? The official explanation is bureaucratic: hiring engineers, finalizing designs, securing land rights, coordinating with property owners along the route. But I found something else in the City Council minutes from January 1836. A brief notation about unexpected discoveries during fire debris removal. No details, no follow-up. Just that phrase, buried in a procedural report about reconstruction efforts. When I searched for related documents, damage assessments, engineering surveys, excavation reports from the fire cleanup, I found the same pattern. General summaries exist, financial records of reconstruction costs exist, but technical reports about what they found underground during the cleanup, filed away, marked internal reference only, or simply missing. I went back to the wooden pipes. The 2006 excavation report included photographs, close-ups of the wood grain, the iron bands, the tapered connections where one log met the next. But there was another detail the report mentioned in passing. The pipes were discovered at an intersection where 3 streets converged: Beekman, Water, and Pearl. I checked a 1799 map of Manhattan. That intersection didn't exist in 1799. Pearl Street ran along what was then the shoreline, the eastern edge of the city before landfill extended it further east. Beekman Street existed, but Water Street was still underwater. The land where those pipes were buried wasn't created until the 1820s. So either the pipes were laid after 1820, which contradicts the archaeological dating, or they were laid before the land existed, which doesn't make sense, unless they weren't laid at all. Unless they were already there and the Manhattan Company workers connected to something that predated their construction. I found one more document that nobody talks about. Christopher Calls, an Irish engineer, proposed a water system for New York in 1774. He designed a network of reservoirs and distribution pipes using steam-powered pumps to draw water from wells. Construction began in 1775. The British Army arrived in 1776. According to every history of the period, the British destroyed Calls' system during the occupation. But what does destroyed mean? Above-ground infrastructure, certainly. The pumps, the reservoirs, the visible components. But underground pipes, buried distribution lines? The historical record says they were destroyed, but provides no details about how or when. And then, 23 years later, Aaron Burr's Manhattan Company starts laying pipes in the exact same area. Did Burr's workers discover Calls' network still underground? The construction records that would answer that question don't exist, or rather, they existed in 1891 and disappeared after the 1911 fire. Conveniently. Here's what we're asked to believe. Aaron Burr's company raised $2 million, spent $100,000 on infrastructure, and created a water system that, despite being crude, inadequate, and frequently frozen, operated for 43 years. They used hollowed logs that somehow survived 2 centuries underground in conditions that should have destroyed them. They laid pipes in locations that either didn't exist yet or connected to routes established by an earlier system that was supposedly destroyed. The technical documentation explaining how they accomplished this disappeared in a fire 80 years after being archived, and 4 months after voters approved a replacement system. The Great Fire of 1835 revealed catastrophic infrastructure failure, but construction on the new system didn't begin for 2 years. during which time workers made unexpected discoveries during debris removal that were never publicly documented. None of this proves anything, but it forms a pattern. The Croton Aqueduct finally opened on July 4th, 1842. Water flowed from the Croton River, 41 miles away, through a masonry aqueduct built at a 100-foot elevation drop, arriving in Manhattan by gravity with enough pressure to serve the tallest buildings and fight fires. New Yorkers celebrated with fountain displays and parades. The system was hailed as an engineering triumph, the first truly modern water supply in American history. The Manhattan Company's wooden pipes were officially abandoned. But here's the detail that caught my attention. When the Croton Aqueduct system was designed between 1835 and 1837, the engineers, led by John B. Jervis, conducted extensive surveys of Manhattan's underground. They documented existing infrastructure, the locations of the Manhattan Company's pipes, the routes those pipes followed, the underground chambers and reservoirs Burr's company had built or connected to. Those surveys would have revealed everything: what was original construction from 1799 to 1802, what predated it, what the Manhattan Company had inherited. I requested access to those survey documents from the New York Public Library's archives. They have Jervis's reports on the aqueduct construction, his engineering specifications, his correspondence with city officials, but the underground surveys from 1835 to 1837 are collection status unknown. Materials cannot be located in current holdings. The same answer I've gotten for every document that would explain what they actually found underground. I went to look at the Croton Aqueduct's distribution routes through Manhattan. The system connects to underground tunnels that follow specific paths through the city, paths chosen because the ground conditions were optimal for large-scale excavation and long-term stability. When I overlaid those routes on a map showing the Manhattan Company's 1799 to 1802 pipe locations, something became clear. They align, not approximately, not in the general vicinity. They follow the exact same corridors, as if whoever laid the wooden pipes in 1799 already knew which underground routes would still be viable 150 years later. And as if whoever designed the Croton distribution system in 1835 was following paths established long before either project officially existed. Modern New York gets its water from three systems: the Croton, Catskill, and Delaware aqueducts. The original Croton system, the one built after the 1835 fire, was expanded in the 1880s with a larger aqueduct and new reservoirs. That expansion required extensive underground work throughout Manhattan. Engineering reports from the 1880s mention encountering unexpected structures during excavation, chambers that weren't on city maps, stone-lined passages that didn't match any known construction period, distribution tunnels that connected to unknown origin points. The reports note these discoveries, while then dismiss them. Remnants of earlier private construction or unrecorded infrastructure from colonial period. No investigation, no documentation, no curiosity about how colonial-era construction managed underground work that 1880s engineers with steam-powered industrial equipment found challenging. Just acknowledgement, dismissal, and moving on. By the 1890s, references to these discoveries disappear from public reports entirely. The pattern holds. In 2013, New York began construction on Water Tunnel No. 3, a massive project to provide the city with a critical third connection to its upstate water supply. The tunnel is over 60 miles long when complete. It runs deep below Manhattan through bedrock that requires tunnel boring machines and explosive charges to penetrate. During construction, workers broke through into chambers that weren't supposed to be there, stone-lined, precisely cut, extending in directions that didn't match any city infrastructure plan. I found one reference to this in a construction supervisor's report, filed with the Department of Environmental Protection in 2015. The report noted uncharted underground spaces encountered at multiple points during excavation, origin unclear, filled with concrete per safety protocols. Filled with concrete, not investigated, not documented, not studied to understand how they were built or who built them, just filled with concrete and sealed. When I requested additional documentation about these discoveries, the DEP response was brief. Safety protocols for unexpected subsurface conditions are standard procedure. No further documentation exists. The same answer every time. Ask yourself this: if Aaron Burr's company spent $100,000 building a water system from scratch in 1799, how did wooden pipes last 2 centuries when wood shouldn't survive underground for 2 decades? If the system was crude and inadequate from the beginning, how did it operate for 43 years? If Christopher Call's earlier water system was destroyed by the British in 1776, what underground infrastructure did the Manhattan Company connect to in 1799? If the 1835 fire revealed catastrophic system failure, and voters had already approved the Croton Aqueduct in April, why did construction not begin until 1837? And what unexpected discoveries delayed the project? If the Croton Aqueduct engineers conducted comprehensive underground surveys in 1835 to 1837, why are those surveys missing from every archive I checked? If modern water tunnel construction keeps encountering uncharted underground spaces that predate known infrastructure, why are they filled with concrete instead of studied? Unless the answer to all these questions is the same. Unless New York's water infrastructure wasn't built from scratch in 1799 or 1842. Unless what we call construction was actually connection, linking modern systems to something already underground, something mapped and functioning centuries before the official timeline acknowledges. Unless the Great Fire of 1835 revealed more than infrastructure failure. Unless it exposed an underground network nobody was supposed to see. And unless the 2-year delay before starting the Croton Aqueduct wasn't bureaucratic at all. Unless they were deciding what to do about what they'd found. The wooden pipes discovered in 2006 are now in the New York Historical Society's collection. You can see them if you visit. 2 hollowed pine logs, bark attached, iron bands still in place, tapered connections still intact after 200 years underground. The museum placard explains they're from the Manhattan Company's 1799 water system. It mentions they were remarkably well preserved, and notes the tar coating that supposedly protected them. It doesn't mention that wood preserved this way should still show deterioration after 2 centuries. It doesn't mention the archaeological dating conflicts with the land where they were found. It doesn't mention Christopher Call's earlier system or the routes that align too perfectly or the missing survey documents. It presents them as artifacts of early American ingenuity. Clean history, simple explanation, nothing mysterious. I kept digging through city records, looking for anything that might explain the pattern. I found one more detail buried in a New York City Water Commission report from 1858. The commission was reviewing the Croton system's first 15 years of operation. They noted that certain distribution routes through Manhattan were experiencing unexpected longevity with minimal maintenance required despite high usage volume. The report attributed this to fortuitous soil conditions and superior initial construction quality. But then there's a footnote. Brief, easy to miss. Routes aligned with pre-existing underground conduits of uncertain origin provided advantageous structural support. Commission recommends continued utilization of established pathways for future expansion. Pre-existing underground conduits. Of uncertain origin, one sentence, never explained, never followed up. The recommendation was implemented. Future expansions did follow those same routes. And the uncertain origin was never investigated. New York today has one of the most extensive underground infrastructure networks in the world. Water tunnels, subway lines, electrical conduits, telecommunications, cables, steam pipes, sewers, all running through an intricate web beneath the city. The official maps show when each system was built. 1842, Croton Aqueduct. 1904, first subway line. 1920s, steam system expansion. Clean dates, clear progression. But workers who actually maintain these systems know something the maps don't show. I spoke with a transit authority engineer who's worked on underground infrastructure for 30 years. He wouldn't let me use his name. We find things, he said. Chambers that aren't on any blueprint, passages that connect systems that shouldn't be connected, stonework that doesn't match anything from the periods we built. What do you do when you find them? Seal them. Mark them as unknown infrastructure. Do not disturb. Move on. Does anyone investigate? Why would they? The systems work. Everything functions. Opening an investigation means delays, budget inquiries, historical complications. Easier to seal it and forget it? How often does this happen? Every major project encounters something. We just don't talk about it. The conversation was off the record. He wouldn't provide documentation. But he did mention one thing. The really strange part isn't finding the chambers. It's finding them in locations we supposedly built first. Like the infrastructure we laid down was connecting to something already there, and whoever designed our routes knew exactly where that something was. Consider what we know. In 1774, Christopher Columbus designed a water system. The British supposedly destroyed it. In 1799, Aaron Burr built a system with $100,000 that lasted 43 years on wooden pipes that shouldn't survive 2 centuries. In 1835, a fire exposed infrastructure failure. Voters approved replacement. Construction delayed for 2 years. Unexpected discoveries during cleanup were never documented. In 1842, the Croton Aqueduct opened, following routes that aligned with the earlier wooden pipe system. In the 1880s, expansion work encountered unexpected structures and unknown origin points. In the 2000s, modern tunnel construction keeps finding chambers that aren't on any map. Each generation encounters the same thing, underground infrastructure that predates the official construction timeline. Each generation seals it, notes it briefly in internal reports, and moves on. The public history remains clean, simple, progressive. While underground, the same chambers keep appearing. waiting, connected, functioning. When you turn on a faucet in New York City, water flows through systems we're told were built in 1842, 1885, 1917, 1954. Clean dates, modern engineering. But the routes those systems follow were established before any of those dates. The chambers they connect to were already there when construction began. The infrastructure works too well for something built from scratch, and the documents that would explain how, the surveys, the excavation reports, the discovery records, are all mysteriously missing. Lost in fires, status unknown, cannot be located. The same answer every time. The wooden pipes in the New York Historical Society are real, 2 centuries old, perfectly preserved, still connected. The fire of December 16th, 1835 actually happened. 17 blocks destroyed, infrastructure failure exposed. The delay between voter approval and construction start is documented. April 1835 to 1837. The unexpected discoveries notation in city council minutes exists. The missing survey documents are verifiable absences, catalogued but unavailable. The modern tunnel workers do encounter chambers not on any map. These aren't theories, these are facts. Well, what makes them strange is the pattern. A system that shouldn't work for 43 years works perfectly. Pipes that shouldn't survive 2 centuries are found intact. Routes that shouldn't align across different construction periods follow identical paths. Documents that should explain all this keep disappearing, and every time someone uncovers something underground that doesn't match the official timeline, it gets sealed, dismissed, and forgotten. Not once, not twice, for 2 centuries. The pattern isn't evidence of conspiracy, it's evidence of inheritance. Evidence that what we call building. New York's infrastructure was actually reconnecting to something already there. Something mapped long before 1799. Something functioning long before Aaron Burr's scheme. Something we've decided, deliberately or not, to stop asking questions about. The Great Fire of 1835 didn't just reveal infrastructure failure. It revealed the truth every generation of New York construction workers has encountered since. There's more underground than we built. The routes we follow were established before we arrived. The chambers we discover predate the city's official history. And the only reason the system works so well is because we're not building it. We're just maintaining what someone else left behind. Someone we've agreed not to remember. Something that works too well to be forgotten, even as we pretend it was never there at all.